Today I'll be showing you how to do AP problem number 9. The graph below shows the result of the titration of a 25 milliliter sample of a 0.1 molarity solution of a weak acid HA with a strong base of 0.1 molarity NaOH. So here's our graph. First, we are asked to describe two features of the graph above that identify HA as a weak acid. So one of those features is that the pH at the equivalence point is greater than 7. As you can see here, the equivalence point is somewhere around here, and that pH would be around 9. Another feature would be that the rapid increase in the pH after adding a small amount of base. As you can see here, once you add a little bit of base, the pH goes up compared to this other graph. B says describe one method by which the value of the acid dissociation constant for HA can be determined using the graph above. You can do this by identifying the equivalence point, because the equivalence point means that the pH will equal the pKa, and if you have the pKa, you can solve for the Ka by doing 10 to the negative pKa, and that gives you the Ka value which they ask you to find. C says, on the graph above, sketch the titration curve that would result if 25 milliliters of 0.1 molarity HCl were used instead of a 0.1 molarity HA, and this would be the graph. See the difference? Once you add a little bit, the pH doesn't go up until you add a lot more, and it has the same ending as the other graph. D says a 25 milliliter sample of a 0.1 molarity HA is saturated with a 0.2 molarity NaOH. What volume of base must be added to reach the equivalence point? So for this part, we know that if you multiply these two together, we get the 2.5 millimoles and then of HA, and that equals 2.5 millimoles of OH minus, and then you just divide that 2.5 millimoles by the molarity, which is 0.2, and you get 13 milliliters is the volume of the base that must be added. Then it says the pH at the equivalence point for this titration is slightly higher than the pH at the equivalence point in titration using the 0.1 NaOH. Explain. So as you can see, in the 0.1 molarity, the total volume at equivalence point is 50 milliliters, and in the 0.2 molarity, the total volume at the equivalence point is 37.5. So the smaller volume of the 0.2 molarity means that the concentration of the conjugate base is larger than the concentration of the conjugate base in the 0.1, so the pH is slightly higher. And that is it.